All right, Kevin Culp back at you from Supermicro. Today's presentation, we're going to focus on simulating a leak at the cold plate. We're going to do things a little different this time around. Instead of navigating through the web GUI and providing more of a live type of look and feel, because there's so many things going on related to this, I thought it would be important we set up a sandbox and do our video clip. And we'll stop the video clip periodically and talk about important features exposed within this particular feature of liquid cooled data centers. And then, of course, it's centered around prototyping and simulating a leak. So before I start with the rolling of the video clip, the first thing I really want to talk about is by default, enforcement policy, which is a global setting, is disabled. So why have we set that particular feature or that particular setting to disabled? Because not all customers are going to take a liquid cooled solution within their data center. There will be some customers that will typically align with air-cooled data centers and other customers that will be focused on what we refer to as liquid-cooled data centers. So by setting it to disabled, enforces the DevOps administrator to enable that feature set so that we can set the enforcement policy. So let's go ahead and roll the clip. And then again, I said I'll stop it periodically and talk around the various different use cases and value proposition that our platform focuses on specific to liquid cooled data centers. So as I mentioned before, we set the enabled feature, and that again turns on the global setting. We're then going to jump to PodView. And PodView, I'd like to talk about is we talked about this in other video clips about the importance of PodView of logically representing racks within your data center and how those applications may be defined associated with workloads that are running on servers. So defining a group or grouping them based on common workloads becomes very attractive to DevOps administrators to organize their data center virtually so that they can drill down to specific servers and understand what applications are running on those servers. So we expose this information also in different ways. In the compute side, when an operating system gets deployed, we automatically will indicate the type of operating system is deployed, and we give users the ability to set applications through our tag management functionality within compute. So the first thing I want to point out to you is these two icons on the tree architecture. The first one represents a PDU managed rack, and the second icon represents a liquid cooled rack. So both of them are in and assigned to this particular rack. So the electrical socket represents the PDU, and the water droplet represents the liquid cooled data center or a CDU that's associated with this rack. We're simulating an AMD liquid cooled SKU. So that's the AMD-based AS4125GS. And we provide a visual representation of front and rear view and information that you can collect. That is, our agents are collecting based on Redfish. They collect that data, we package it up in a unified dashboard experience, exposing it through what we call PodView, which is a hallmark feature within SuperCloud Composer. And you can click on the IP address here that would give you the ability to connect into the BMC. But the whole purpose of an enterprise management solution is to minimize the number of clicks it takes to get the appropriate information you need to define a task specifically for a server architect. On the left-hand side here, you can also see rack slot unit is the position always where an in-rack CDU gets placed, and that provides you with an IP address. And then also this server is showing in good standing with a check mark to indicate that There is no failure at the component level or at the server level. So it's in good standing, and the health rollup is good. So I'm going to roll the feature again, and or the actual video clip. So let's roll it. And the next thing we're going to point out is the compute. And when you click on the compute tab on the top here, we provide all of the lifecycle management functionality associated with a rack. And that's on the top here. We indicate so here. So let's stop it for a moment and just review it. Let's go back here a little bit and show you that information. So here we see the lifecycle management buttons of here that you can perform associated with the server. We can look at interesting things about this server, such as it's a product family is GPU, product family, its product SKU, the power status is on, and then also you can click here to the BMC. If you were to click here, it would redirect you back to PodView, showing you the look and feel of the server. A discovery state is basic. Array state for simplified storage is set to none. And then if you click here, we talked about in a previous video where you can collect and data mine information about a particular server for its use case. And you can take that data and perhaps import it into an Excel spreadsheet and utilize pivot tables to mine the data that you're looking specifically for your use case. So let's continue on with the video, and the power status is set to off. And the next thing we do is we're jumping into the BMC of the CDU. So all of this data can be set within the CDU itself if you have settings that need to take place here. This information is available through Redfish. So potentially, maybe there is customers out there that want to build their own particular dashboard and they want to rely on the source of truth being the BMC for CDU. The value proposition SuperCloud Composer does is we've done all that for you and provided it in a unified dashboard experience for DevOps administrators utilizing the data center. So the other thing I'd like to point out is the auto is set, and also the control unit is in a good standing. So we have not detected a leak at this point. So all of the glycol and water is flowing through the CDU, and there's an intake and also a return. So that information is being passed across the cold plate based on the consistency of the glycol and water, and is cooling down either the GPU or basically the CPU. So clicking on, or next thing we're going to do is show you the PDU console. And the PDU console is how we system power map servers to basically the PDU. As I mentioned, Universal Agent is created here, and you could obviously here be able to control the outlet by shutting it off. That capability is available to you. Things to point out here, it's in rack B6 in rack slot unit 7 is the server and the outlet that's associated with it. And you'll notice here it's in an on position. So what we're going to do is simulate a leak at the cold plate by injecting metadata to simulate that into actually the Swagger or the payload. And you'll see that in a few moments when things start to be enforced. So again, you can collect any data that you want associated with the PDU, sensor data, performance metrics, so on and so forth. That's through our PDU console. There's a separate YouTube video that really goes down into more detail about how you collect these performance metrics. So let's roll the video again. And the next thing that we're going to dive into is the enforcement policy itself. So the enforcement policy is where we're going to actually inject metadata into simulating an actual leak. And we're going to inject that into the BMC specifically for the server itself. And you'll see that in a few moments how we inject the metadata. And you'll see at that point we send information through subscription services through what we call webhook. And we call that HTTP relay. So I'm going to roll the video again, and you'll see that we're manipulating and injecting metadata into the payload, simulating an actual leak. And then you see here it's being injected at the cold plate itself. We base it on an IP address through our Redford schema endpoint through JSON. And at that point, we send it off, and we then report basically a leak. So the first thing is taking place here is we've injected this metadata. The CDU sent that alert back to us through Redfish and said, we detect a leak at the cold plate. You'll notice here in the right-hand corner, far as a toast is concerned, we show that information. And if you were to click on this icon, it immediately would go in and give you pertinent metadata of where this is from a rack slot unit perspective, the rack itself, and also the precise location of it within the rack, and what server detected the leak. So all of this metadata is sent through webhook architecture through SMTP. So this information gets sent over to your SMTP relay host with all the appropriate metadata, and you can precisely locate where the leak is, rack location, where it is within the rack. So very, very good information to have DevOps administrators precisely find out where the leak is and quickly take action to resolve that issue. So let's continue on with the video. You'll see here that our admin default leakage protection task was generated through our task. Again, we generated the task through injecting metadata into the actual payload through Swagger. So you saw that in a previous the video clip previous to this, and let's continue on. We'll show here that now the leak was detected. It was completed based on task ID 3837. That default leakage protection is in place. It shows you the BMC IP address. It shows you basically the rack too as well. And then what we've done is we've sent this task to the back end to be able to do the enforcement action. So if you're on the GUI and you're being, navigating around the GUI to do other lifecycle management tasks, you'll never be locked out to the GUI, right? Because all of this information is sent as a task to the back end to perform the enforcement policy itself. So let's roll the camera here. So continually the task is basically running. You can see, as I mentioned before, 3837 is where we injected the leak. Incidentally, while we're waiting for this to respond, I wanted to mention is we as Supermicro are the only particular company in the world that provides a turnkey solution. Everything from direct to chip, rack level management, and also cooling tower. That is very attractive to customers that especially are scaling out large liquid cooled data centers. We have many of these going on today in the globe itself. And also we are the only platform in the industry to support Gaudi systems, Grace Hopper Grace systems, and also MI300. And as I mentioned in the previous video clip, all of the Blackwell chipsets for basically GB200 and beyond are basically now going to be supported based on liquid cooling, including the AMD accelerators such as MI325 that will soon